It's now recording.
Okay, so I would say hi everybody. In the first few minutes, perhaps more of you will join, but we will start anyway, since I will give you some of the organizational information before I'm handing over to Brad. So I'm Sandra Ketelhake, working at the German Marine Research Consortium and JPA Oceans, and being in the coordination team for the AtlantOS project. And so, we very much welcome you to the second Ocean Hour, which has as a topic the gliders. Perhaps you have joined already our first Ocean Hour last month, which was more on the vision and mission and way forward of the AtlantOS program. And so this is just a short recap what we would like to, or why we are offering these Ocean Hours to you. So it's to inform the broader Atlantic Ocean observing community of the advances of the AtlantOS program, the progress of our use cases, and ongoing and new project developments, and as well, like we are doing today, getting you connected or helping you in getting connected within your ocean observing activities. And today we are having this focus on the gliders community. It's about the community engagement and getting your feedback as well for the plans we are having within AtlantOS, and that we can work towards a collective vision for ocean observing in the Atlantic. And so when you're getting our invitations, just share it with everybody who you think is interested in all Atlantic Ocean observing, so that we are getting really a community of practice. And so before we are starting with our presentations, I would like just to inform you that this meeting will be recorded and made accessible after the event on our AtlantOS program website. When you are having questions to the speakers or later on in the panel or for the panel discussion, just use the Q&A box. And if you have any comments, you can write them down in the chat box. If you see that your name is not shown correctly, please modify your name and affiliation under the Zoom settings. And if you would like, you can join us for half an hour optional networking afterwards. There we are using the platform WonderMe, and we will share the link in the end. And so coming to our program for today, we are very happy to get great people working with gliders and who will present their work and their ideas for the future. We will start with Victor Turpin, who's the technical coordinator for the Ocean Gliders program at OceanOps. Then Leonardo Marques de Cruz will give a presentation on the Proyecto Azul. And then we're having, in the end, the open floor and panel discussion where Scott Glenn, Robert Todd, and Sarah Nicholson will be part of as well. And with this, I would like to hand over to Brad DeYoung, who is the chair of our AtlantOS steering committee. I think most of you know Brad. He is an honorary professor now at the Memorial University of Newfoundland and is part of the AtlantOS team since the beginning. So Brad, over to you.
Thank you, Sandra. And let me add again my welcome to everyone. I'm happy we're all here to have this discussion. And you can't see this on my head. Oh, my head's over there. But I'm wearing two hats today. So one of those hats, as Sandra described, is my engagement in AtlantOS, but I'm also co-chair of Ocean Gliders, the international program effort. So this is kind of the perfect meeting for me. I should stay here all day. Our approach here to this discussion is to bring the intersection, for me, I guess, of these two program ideas, one around ocean gliders, which is to support ocean glider operations globally. And there are many things that happen within ocean gliders that we may not talk about so much in terms of best practices and sharing a kind of information around the technology. So this isn't a technology discussion today. It's focusing more around how best to use gliders in programs to enhance ocean observation. And that is exactly the intent of AtlantOS. And so the overlap here, the intersection of these two threads is pretty much perfect. And so we have engaged then the discussion from some of the use case studies in some sense of the Ocean Gliders program, the storms and the boundary currents that Robert Todd for boundary currents and Scott Glenn for storms will be able to speak to and talk about, but also expanded beyond to Southern Ocean interests. So we'll hear from Projetio Azul from Brazilian interest and from South African interest, because we're here focused in AtlantOS around the Atlantic kind of interests in some sense of the Ocean Glider International Program. So the intention then is to hear a bit about this. First, an overview from Victor Turpin, who's been involved in ocean gliders for quite a few years, because some of that development was stimulated from the AtlantOS project, the EU-funded project, which is the precursor to the AtlantOS program. And as Sandra mentioned, Victor is now at the OceanOBS kind of central hub for managing metadata from the international global networks, of which Ocean Gliders is one. So let me pass on to Victor, and then we'll carry on the discussion. So go ahead, Victor.
Hi, everyone. I'm trying to share my screen, but it seems
that you can't. Okay, I will do for you.
Yes. Thanks a lot.
Just let me know if you see the slides.
Yeah.
Perfect.
Yeah, I can see the slide, and I must apologize with the typo in the middle.
Okay.
Anyway, so hi everyone. I'm Victor Turpin, and as Brad said, I'm working for OceanOBS as technical coordinator of the Ocean Glider program. And what I will present you today is the activities we are doing with the Ocean Glider community globally. Next slide, please. So here is a kind of a timeline of the glider network history, let's say, to show how the European project and AtlantOS in particular contribute to improve the international cooperation of the glider network. And to start with, it starts by the Stommels paper in 1989 that describes the buoyancy-driven robots with wings that could contribute to ocean observation. And in the early 90s, in parallel, I would say, the GOOS was established. EuroGOOS was established too. And in 2000, OceanSights and Argo became two associated programs of the Global Ocean Observing System. In 2004, the first glider mission was in Europe was operated by GEOMAR, and 2 years later, a community of users pops up, I would say, and the first meeting was organized in 2006. And in the 2010, the EU pushed a lot to encourage coordination of the glider community in Europe through different programs and projects. And in 2015, AtlantOS started, and the glider community was part of the AtlantOS with the aim of better organizing the observation with glider in Europe. And this gave us the final push to achieve what was written in 2009 by Pierre Testor in the OceanOBS 09 paper. The Ocean Glider program became the glider program of the GOOS in 2016. And since 2018 now, OceanOBS is Ocean Glider is part of OceanOBS, and OceanOBS is monitoring the program Next slide, please. Yeah, thanks. What's Ocean Glider? Ocean Glider, as I said, is the glider program of the GOOS. It's focusing on the science you can do with glider and not on the technology itself. It's focusing on the sustained ocean observing, the long-term physical, biochemical, and biological ocean processes you can observe with gliders. Ocean Gliders is contributing to the international effort on ocean observation for climate, ocean health, and real-time services. And Ocean Gliders is organized around six task teams. The first one is the boundary current, that is sustaining glider observation in the ocean boundaries. The storm task teams aim to increase the extreme weather forecast with glider observations. The water transformation task teams monitor the shelf and open sea water formations and variability. The ocean health and ecosystem task teams observe the variability, the changes, and the stress in habitats. And we have the data management task team that harmonizes the data format globally and supports its implementation. And the best practices task team that is producing documents to guide implementation of glider capabilities globally. And since, as I said, OceanOps is the body that monitor the global glider activity and help to data collection and data dissemination in global databases. Next slide, please. So now I would like to focus on three of those task teams, the storm task teams, the boundary current, and the data management. And what you see here is a brochure that we have produced recently. You can find it on the Ocean Glider website. And it shows on the left the 2019-2020 tropical storms tracks, and the areas define the landfall region of those tropical storms. The colored area are the regions where gliders are used to improve storm forecasting. So why do we need to forecast storms? Because storms have a huge impact on the people living and working near the coast. It's causing hundreds of billions of dollars of damage annually. The relationship between ocean and storms is known, and we need ocean observation to better forecast the storm's trajectory and intensification. And glider provides this capability by operating under storms in a broad range of water depths. Glider can provide real-time data directly under the storm tracks to improve to allow data assimilation and improve the forecasting of the storms. And also the uncertainties in forecasting models provide guidance to decide where and when deploying glider in order to maximize the value of those data. So this task team is working together to organize this activity globally, share the requirements, share the best practices, and increase the number of data available for storm forecast. Next slide, please. So another task team is the Ocean Boundary Task Team. Is focusing on monitoring the ocean boundaries where society feels the effect of the ocean directly. In those regions, the ecosystem are highly impacted by human activities, and those regions have a high economic value for the coastal communities when we think about climate, weather, fisheries, transportation, pollutant, etc. Gliders can deliver operational observation in this region because they can capture the physical, biochemical, and biological variability in this region. They can sample across high gradients along strong currents and in whatever weather condition you can find in these regions. And also, glider effectively integrate with other observing systems along the coast that make it very efficient. And this community is working together to highlight the need of sustained observation in boundary regions. The community, the task team is working directly with the modeler to develop regional products and promoting the need of observation in this region. And the target of this task team, let's say, it's 100 sustained line or areas by 2030. Next slide, please. And the final activity Ocean Glider is doing that I want to advertise as an example today is the data management task team. What the data management task team is doing today, for example, is this mapping of the international gliders data flow. What you see here is a review of the different data flow from the data provider, that are the networks and the glider groups, to the data assembly center, to the GTS and the global data assembly center. And we are trying to map the different formats, the different services that the data assembly center provide to serve the data, in order to have a complete view of the complexity of the glider data flow at the global level. And obviously the aim is to help optimize this data flow and make it looks more simple. Next slide, please. And at the same time, we're doing the same exercise for the metadata, because the Ocean Ops is building its system on the metadata aggregation, and we are trying to map where we are collecting the metadata and how we are collecting the metadata, what kind of process, what kind of format, who's the metadata provider, and how we can connect to the GTS and the Global Data Assembly Center. And this is really a first time we can see how complex the glider data management can be if you think globally. Final slide. Thank you. So that's it. Two keywords to keep in mind, that Ocean Glider is based on scientific cooperation and data and metadata sharing. So if you want to join to the community, if you want to have more information about the work we are doing at Ocean Glider, please connect with me or Brad. And thanks a lot for your attention.
Yeah, thanks a lot, Victor. I think this information is so useful, and yeah, spanning a good overview on where the gliders community is going for the future and where you're coming from. So with this, I would like hand over to Leonardo Marques da Cruz, who is the operational director or director of operations at Oceano, and who will give us now an overview on the Proyecto Azul, yeah, to which we are looking very much forward. And if you are having any questions to Victor or Leonardo already, yeah, just write it down in the question and answer. Thanks.
Thanks, Sandra. First of all, I'd like to thank you all for the invitation, particularly Professor Letícia Cotrim from the Federal University of Rio. So what I came here to share with you guys is our experience on, of course, the usage of gliders, and also, but it's the usage of glider on our context here. In the beginning of 2012, we started to design a project aiming to build one of the first initiatives on operational oceanography here in Brazil based on gliders, I would say. So this is called Projeto Azul. Projeto Azul is an initiative sponsored by Shell and executed by ProOceano and the Federal University of Rio de Janeiro with the laboratory called LANCE, right? So the main idea of the project was to increase our to improve our capability of ocean forecasting, because probably most of you know that in the Brazilian coast, close to what we call Campos Basin and Santos Basin, is where most of the offshore activities going on here in Brazil. So the idea is through the usage of instrumented lines and remote system to enhance the ability to forecast the ocean in a region where we have the Brazilian current flow, all its associated variability in terms of spatial and temporal variability. And the way to do that was to deploy all all what we learned about the operational oceanography into a regional scale domain, making our life easier a little bit, I would say, or mostly not. So then the end product of the system would be to translate the information we were getting from the ocean into the guys that are in charge of offshore operations. So that's why I would show you the end product is a type of dashboard where non-oceanographers or meteorologists can gather information, right? So this is the main phase of the project. So we were basing on ocean observation, mostly independent, and also the ones that will be used to be assimilated in the model. So we used a lot of data management techniques to blend all the information with the results from numerical modeling, assimilating and evaluating the results of the model in as it goes. And in the end, we would be, we put a lot of effort on translating this information to the end user. This is a very important point, since we are a company providing information to another company, right? So another important point is that we try to reduce a lot the usage of vessels. So this is where gliders, drifters, and floats came in hand, because we could reduce it a lot. And mostly of our operations, we used vessels of opportunities, and we normally consider very short campaigns, right? So this is the type of data. It's there's nothing new here for you guys, but it's very important to point that we've been able to execute long-term missions, I would say, for our region. It's important to point that we are focusing on a regional grid. So we've been successful in keeping the gliders offshore and measuring up to 4 months, right? So this here is the type of pattern we are trying to follow in the second part of the project. So basically, our main focus is cross-sectioning the main Brazilian current system flows, trying to infer some characteristics of the flow, right? So of course, we are depicting several information from this transect, like the geostrophic velocity currents. We are trying to depict also and to improve the ability to depict surface currents and the integrated current from the DAC. So this is also something apart from the model effort, right? So this is a kind of resume, a kind of summary on the data we've been able to collect since 2012 and 2013. We have a lack of data from previous years, because there is an interval in the project. So this year 2021, we'll have all the equipments in the water again. So basically, in the phase 1 of the project, we've deployed some SVP drifters, Argo profilers, and we kept the gliders flying like into these 2 paths here. And in the phase 2, we focus only in this one area, in this area here, and this sulfur region, right? So in phase 2, we also put some effort in deploying 2 deep water mooring lines to be used as independent measurements, to not only to evaluate the model, but also to add wave forecast capability also to the system, right? So and again, another new development into this phase 2 of Projeto Azul is the deployment of the ASV. We choose this called the sail buoy equipment, and the idea is to compare the information that we mostly related to waves, to compare the information we could get from a vehicle like that and a wave rider and a ADCP looking forward in the region, right? So this is something that I'm really excited in showing you guys. This is one of the main improvement we could achieve from Project Blue Phase 1, Projeto Azul Phase 1. So one of the I would say one of the most difficult issues we have here in providing a good forecast is to precisely identify where all the mesoscale activities will happen and will start. So this here, in these two panels here, you can, of course, with a little bit of effort, you can see here is a recirculation that we call Cabo Frio edge. It is it's a cyclonic edge that is normally it appears here normally. Normally this frequency is around a couple of months, but the triggers is still not yet completely understood. So with the ability to assimilate the glider information and the profiler's information, we started to be able to better forecast the position of the eddy, not only its formation. As you can see here on the left panel, we have a free run of our ROM's grid. In the black lines, you can see the circulation, and in the blue lines, you can see the SVP drifter trajectories we had at the region, and in the yellow line, you can see the glider path. You can see that in the right panel, it's the model with all the data simulation we built on it. And you can see that we could better reproduce not only the location of the eddy, but also the right positioning time also. So this was a very interesting result, right? In terms of regional grids in the project, we have two ROMS grids, 112 and 136. With 4D VAR data simulation, and now we are putting a lot of effort on the wavewatt grid and also the WRF atmospheric model to complement the system as we move on. So, and in the end, of course, we need to translate all those informations to the ones that are paying for the project, of course. So we put a lot of effort into this translation. Here we develop a dashboard where the operational managers could program their operations, like with all the thresholds and all the problems they might foresee. And the system used the information we are getting from the nowcast and the forecast to try to give an overview on the following days for them to at least to have a better forecast on a go or no go situation, helping them to better manage their operations, right? So just the last slide I wanted to share, I would like to highlight some points that we think they are very important to our project. So our idea here is to improve our regional forecast capabilities, right? So to do that, we decided to invest on remote equipment and reducing a lot, trying to reduce as much as we can the usage of vessels, right? All the regional grids are nested in global models. Normally, we've been testing commands and HICOM from Encoder. The data simulation are proved to enhance the forecast capability, in particular with the mesoscale features we've been seeing in the area. And in the end, the dashboard, we think we've been successful in translating this information. Of course, this dashboard is brand new. It was released last month, actually in January. So there's a lot of room to improve, and we are interacting with the users of the system to try to make it even better. Okay. So thank you very much, and I'm open to discussions.
Yeah, thanks a lot, Leonardo. That was a pretty nice, showcase of a project that is using gliders for improving, information products. And before we are going to the panel discussion, I think we can, or it might be nice if you can answer a question that have been asked by Martin Fisbeck, who's part of our steering committee. And he's asking, Leonardo, is this part of a strategy to measure Western boundary currents? I seem to recall that this was a challenge set out from the Goose community as well.
Yeah, thank you for the question. This is a project completely apart, but I forgot to mention that I am taking the lead of this project from this year. I'm replacing my colleague Francisco dos Santos, who was in contact with also the Goose project, and we are trying to interact with the Western Boundary project. So. Yeah, those initiatives are different, but we are aiming to collaborate.
That's perfect. And I hope, Martin, this probably answers your question very well. So yeah, and then we're having a comment in the chat that Mauro Cirano, you might know him, would like just to keep you posted that they are planning to start a repeated XBT line in a region very close to your Southern Lights. So perhaps, Mauro, you would like to join us for the Wonder Me session in the end, and then you can get in direct contact with Leonardo. So yeah, with this, thanks for our two presenters who will be part of our panel discussion, which starts now. Just let me share one more slide with you where you see, oh, sorry, now we have to go through all of these slides because I clicked, let's start from the beginning. But yeah, so now we are at our panel discussion. So I welcome very much as well Robert Todd, who's working at the Physical Oceanography Department at Woods Hole Oceanographic Institution in the US. Then we're having as well Sarah Nicholson, who is part of the Southern Ocean Carbon and Climate Observatory at CSIR in South Africa, and Scott Glenn, who is at the School of Environmental and Biological Science at Rutgers University in the US. And perhaps, or I would like to invite all our panelists who haven't presented now. Perhaps we can start with Robert. Yeah, just to explain what you're doing a little bit more, and how this can relate to AtlantOS, what we're doing here, what you've heard from the others, and where you see opportunities or gaps for the Gliders network in the future.
Okay, great. If you can, hand off the screen. I'll put mine up. So hi everyone, I'm Robert Todd from Woods Hole Oceanographics. And I'm a member of the steering team for the boundary currents component of ocean gliders as well. So not surprisingly, I'll lean on the role that gliders have to play in the boundaries as we build up the observing system. And as an example of that, I'll focus on my work, which has been largely along the US East Coast over the last several years. So the map here is just showing from the Florida coast around 25 north up to almost the latitude I'm sitting at now in Woods Hole, covering about 15 degrees of latitude along the western boundary of the North Atlantic. And of course, the major oceanographic feature along that part of the ocean is the Gulf Stream flowing north very rapidly. It surface speeds in excess of 2 meters per second. Depth average speeds over the upper kilometer of order a meter per second. So it's a challenging region to work in, but by combining a bunch of different observing assets, gliders included, we've started to build up a pretty solid observing system in the Gulf Stream region along the East Coast. So the map here is to give you an example of how all of those components of the observing system work together. So for several decades now, there have been cable-based measurements across the Florida Strait down here in the southern end. laser pointer, southern end measuring the volume transport through at the beginning of the Gulf Stream as it comes out of the Gulf of Mexico and heads up the east coast of the US. And likewise, there have been several ship-based survey lines. So an XBT line here coming, this is the AX-10 line. There's the Oleander line, it's a container ship running from New Jersey to Bermuda frequently. And for a decade, there was also a array called Line W that was based on moorings and ship stations. And you can see those have provided decades of measurements at select points along the Gulf Stream and at fixed locations. So ships go back and forth across the same place. But there's also a large gap here, some 1,500 kilometers of Gulf Stream between the Florida Strait and these several lines downstream. The Gulf Stream in that range triples its volume transport, leaves the continental margin at Cape Hatteras, and becomes this free eddying jet in the open North Atlantic. So there's a lot going on between those observations. The next big piece of the puzzle added in, starting in the late 1990s, so more than 20 years now, of course, is the Argo program. And all of the little blue dots on the map here are locations of Argo profiles in a 5-year period from 2015 to 2019. There are about 7,500 Argo profiles in that time. And it's pretty clear that Argo does a really good job of providing broad coverage of the deep ocean. That's what it's designed to do. It does a spectacular job of it. It's really is the backbone of our subsurface observing system for the deep ocean. What Argo was not designed to do was provide high resolution measurements right along the boundaries. The nominal spacing of floats at any given time is about 3 degrees globally. The Gulf Stream is only about 100 kilometers wide. So it's not really going to be resolved at any particular time by Argo. Argo wasn't designed to do that. Argo floats also drift at a depth of 1,000 meters and profile down to 2,000 meters, meaning that they rarely make it into the shallower water. So there you can see over here, the shallower region, it's a plateau about 800 meters deep that the Gulf Stream flows over. There are very few Argo profiles. So this is where gliders then play a really complementary role because they're able to work in shallower water. They're able to provide very high resolution measurements, and they can fill the gaps between these other platforms. So the orange dots here are the locations of glider profiles from my group over that same 5-year period, and there are about 22,000 profiles in that time period. And you can see they're very much more concentrated in the Gulf Stream because we're targeting the Gulf Stream as the key feature we're measuring. So the gliders really do a nice job of bridging between the continental shelf and the deep ocean and filling that gap between what Argo does so well and what we do with the coastal observing systems. So that's one example from one region of what Boone is trying to build up, this boundary ocean observing network through ocean gliders, where we're trying to build up globally, where we have on the order of 100 sustained boundary observing lines with gliders playing a real role in the observing system. So I'll leave it there for now and maybe hand off to the next person.
Thanks, Robert. And I think by showcasing the other observing platforms or what is there that we can use for observe the ocean, it becomes pretty clear, okay, we really need this integrated system. So as you said, gliders are filling a gap, but yeah, we need to work on the integration and the data sharing and data infrastructures, I think. Going to the south, I would say then, or invite Scott to present his work in an area where, the Project Azul is as well placed. So Scott, if you would like to share your ideas and thoughts.
Is that sharing?
Yeah, it is, but it's not in the presentation mode.
How about now?
Yeah, that's perfect.
Okay, I have 3 slides here. 3-minute introduction to hurricane gliders. Up in the upper left is our motivation, this table. This is the billion-dollar disasters over the last 41 years in the US. And right at the top, you see tropical cyclones, the hurricanes, nearly $1 trillion in damage under costs. If you compare it to all the other weather and climate disasters, there's more damage to from hurricanes than all other disasters combined. And there's nearly as many deaths as all others combined. So this is very important for us. So this means that we need better forecasts to help inform all these people We need to know where the track of the hurricanes are going to go, and we need to know what the intensity of the hurricanes is so they can decide whether to evacuate or not. And we have to do that days in advance. And we know that the regional models that we use to forecast hurricanes, they're embedded in a global system. And that global system, the interaction with that global forecast, provides very good estimates of the track. The intensity, though, is partly due to the coupling with the ocean, because the warm ocean will intensify a storm and the colder ocean will weaken a storm. And we find out that if we look around the areas along the hurricane path, we find different, what we call essential ocean features that impact the hurricane intensity along that track. And you see some of these here. Robert just talked about the Gulf Stream and the shelf being very important in the mid-Atlantic. We have other areas where the loop current, the warm pool, the freshwater barrier layers, or in our case in the mid-Atlantic, the cold pool stratification in that area. These are very important for that, for the hurricane intensity. And our approach to that is shown in the bottom left. And it's like a soccer game. We're not the hurricane hunters. The hurricane hunters, they dress in white and they fly through the air and they chase the soccer ball. They chase the hurricane wherever it is. We're more like the goalies. We dress in yellow and we protect that the homeland there during these landfalling events. And so it's those hurricanes that are making landfall that are important to us. All right, next slide. So we've been doing this for 3 years now, where we've been occupying the hurricane glider, the hurricane picket lines along the east coast of the US. And you see the tracks there. This is a very partnership oriented program. You see all the partners down there in the lower right, divided by region. All kinds of sectors are involved, from NOAA, the Navy, academics, industry, foundations are supporting this. And if you up on the map there, you see that for our 2020 hurricane season, we had 16 different institutions contributing glider data to the hurricane picket lines, 78 glider missions total, 3,000 glider days, 163,000 glider data profiles were collected. And the system that Victor showed at the beginning that gets all that data to the GTS, that's the critical piece that then gets it into the hurricane forecast models. It's assimilated there through the global models. And so anybody can contribute to this activity, wherever their glider is, as long as they're sending their data, as Victor describes, through the GTS to the global data tanks. And if you look at the annual statistics, we see we're doing 50% more than we did over the last couple of years. The third slide, oh, that's me. Okay, this data, where does it go? For hurricane models, the data assimilation, that whole value chain starts at the global scale. So it's the global scale models that are assimilating the data. In this case, in 2021, we are switching over to the NOAA real-time ocean forecast system as the starting point of that value chain from for assimilating the data. And you show the example. I show the example here where we've looked in one of those regions, the Gulf of Mexico, where there happens to be a glider located there in 2020, and we do a comparison then of what the glider data says compared to the NOAA model, the Navy model, and the European model. So we're comparing all of them for every glider every day that's reporting in this hurricane network, so we can see how the different models are doing. And I very carefully chose a day and a location where all three models agree quite well with the data, so nobody feels insulted. That's not the typical case, even though they all are seeing this data. And then the last piece on the right is just some examples of some of the more transatlantic glider missions that we've done in the past, where most of these missions were educational. They're in the early 2010s type time period. And it was one of these challenges for students to use these global ocean models and to navigate both the real ocean and the virtual ocean simultaneously and see how much guidance they received from those ocean models. And one thing we noted by doing this exercise over so many years is that our ocean models are getting pretty good, but there's still some work to do. And that data assimilation that we're working on with the gliders anywhere in the Atlantic is going to help us with the hurricanes there. So this is a wonderful place for collaboration across the Atlantic. Thank you.
Yeah, thanks, Scott. And I think it's quite nice to see how these data are improving our information products in the end and help people to, stay safe, and our governments how to, inform the people about what's happening. And thanks for showcasing as well the transatlantic part you've showed, because that goes quite well to Sarah, who's working in South Africa. And Sarah, you might want to tell us a little bit about the connection we might want to approach with AtlantOS and the Southern Ocean Observing System.
All right, hi everyone. Can you see my screen?
Yeah.
Well, I'm thrilled to be part of this panel discussion. Thank you very much for inviting me. So as Sandra mentioned, I'm Sarah Nicholson. I'm part of the Southern Ocean Carbon Climate Observatory. I'm a researcher based there, and I have been co-leading the glider observations in the Southern Ocean that SOCO has been carrying out. So the first glider deployment that we carried out in the Southern Ocean was in 2012. And the sort of motivation for this infrastructure was that in the late 90s, early 2000s, we had a lot more satellite coverage of the Southern Ocean, and it really revealed quite a complex, it illuminated quite a complex ocean that's filled with different spatial and temporal variability. And so we realized that actually we can't just rely on these single ship transects to really understand the processes that are occurring there. We need to move towards gliders. And so we have been deploying gliders, as I said, since 2012. To date, we've completed 22 multi-month deployments. And these often are multiple, like two twin coupled gliders that sort of help you to understand the atmosphere ocean processes. So what I thought I would do is just to talk through some of our, what I think the value of doing these kinds of observations, but also moving towards the basin scale. And so, these three gliders that you see here, these are sort of basically three regional sites that we've been observing since 2012. And we've got a lot of information from these sites, but it's a very local scale. And so we understand the processes very nicely, and this is what gliders enable. They enable process understanding. But what we don't necessarily have a good view of is, well, how does that fit into the remote or large scale? And I think really connecting the glider program with other observations and really integrating it across, for example, across the Antarctic, across the AMOC, I think that is key for us, because this is a map here of CO2 flux, which is, given that I work at the Southern Ocean Carbon Climate Observatory, our focus is really trying to understand how carbon is fluxed into and out of the ocean. And so connecting this large scale overturning circulation with these local scale processes is really a valuable thing. Another point that I can speak to, which is really that gliders are key in providing observations in really difficult to observe places. So in the last, I think 3 years ago, we deployed a glider in the marginal ice zone. And this is I think this was the first glider deployment in the Antarctic marginal ice zone. And it's a really climatically important region, and it's a blind spot. We don't have many observations. And so those glider observations are really quite revealing in understanding the sort of fine scale interactions between the ocean and the ice. So a point that I thought might be of interest is this map that I'm showing you here is a CO2 outgassing and uptake. And the map was generated by Luke Greger when he was working at SOCO. And it's a statistically inferred map. It's using machine learning products to take in satellite products and ship observations to generate, using machine learning, this sort of map, as I said, statistically inferred map of CO2 flux. And I really think that something to think about would be moving forward is to use these high resolution observations to improve this kind of product. And these products are really valuable for evaluating Earth system models. And also they have been extremely revealing in just understanding global carbon products. So yeah, I just think that that's an interesting perspective to look at. Yeah, I won't speak too much more about these points because I guess they will be discussed further. So I'll stop there. Thank you.
Yeah, thanks a lot, Sarah, for these views. And especially mentioning, so where you can, for example, or you see chances for connecting to the Atlantic community as well. And thanks as well for pointing to the carbon map. I know that we have some people in our participants. So for example, I just see Tosta's name, who's the coordinator of the UOC program, and they are looking at carbon fluxes. So Tosta, you might want to join us for WonderMe and get in contact with Sarah. And so far, I would like to, we are having another question that is going to Scott and what you've presented with the hurricanes. So Martin is asking, who's your main customer these days? Is it science, hurricane, or general ocean situations?
Well, all of those people benefit along that value chain because hurricanes, for the hurricane glider fleet, now 2/3 of it is dedicated hurricane gliders. And so it's increased every year. So 1/3 is people out doing their other science activities that want, that criteria to credit. They might be a company that's out there. They want to be able to say they're helping forecast hurricanes for their own operations. And so they share the data. So the sharing of the data is a very important piece of it.
Okay, thanks. So I think for the data sharing points, not quite sure if any one of you would like to come in as well. So do you see that their improvements can be made or has been made? And Brad, you might have as well a question that you would like to address to one of the panelists, but I see Robert would like to address the data question perhaps.
And I didn't have a particular reply, just
Okay.
getting off mute if we got there.
But maybe I'll ask, each to comment on the kind of the challenges of building and what are the present challenges around kind of making the connections, because each of the kind of topics we heard about are trying to kind of connect beyond the glider measurements and to connect to, various aspects of how to use these data more broadly. And so, the challenges could be around data sharing or data kind of management issues, but more broadly about forming partnerships. But maybe, you could each respond as to, what are those challenges and how do you kind of move forward to be, to build the bigger program, the ambition.
Yes, I can say something to that. I think in the US, we have a fairly solid pathway now for getting the data out there, particularly in real time. The post-process data flow is a little more ad hoc, or making post-process data available. But one of the challenges is knowing what happens to the data once it goes out, who's using it, and keeping track of how it's getting used. There are a lot of times that once the data goes out, depending on how it goes, metadata get stripped. This particularly happens with what goes into the operational US Navy flow. They don't even get it with much metadata attached because of the way they accept the data. So we know we're sending our data out there, but we don't often have a good idea of where it's getting used unless we're able to connect directly with, say, a model, someone actually running the model who can go in and say, yes, we got your data in our model. losing track of that data makes it harder for us as the operational folks to answer those questions from the broad community, or from the practical standpoint, our funders, of who's using our data and making use of it. It has to be more than just the PIs doing their personal science goals out of it.
Yeah, Scott,
Yeah.
similar kind of.
Well, I agree that we have to be able to better track our data through the models all the way through where they're assimilated in the increments. And so that requires tools to be built, and that requires somebody to pay for that. And so that's an important piece. The other piece that I want to mention is the international collaboration. I think that's a very important piece of this, and an important opportunity. The hurricane glider lines that we're doing here have mostly been US. To go into other people's water with gliders, you often need permission for research. And so how can we do this as a more operational activity, just like we do for Argo? Can we designate some of the hurricane gliders with SOLAS variables so that they can roam across the EEZs for the common good? I think the UN decade provides us an opportunity to perhaps take a step in that direction.
I say
Yeah,
on that note,
Go ahead, Robert. Yeah.
I say on that note about EEZs, that is one of the big issues, because if gliders' main role is along the boundaries, be it for the boundary current systems themselves or for hurricanes or whatnot, those areas are by definition within the EEZs of the coastal states. One of the goals within particularly within Boone, as we try and make this global network of boundary current observing systems, is to build that capacity in each of those coastal states, so that in the end, we may be able to get a few gliders approved to go into other countries' waters, but in reality, most of the work in a particular EEZ is going to need to be done by people from that country with funding from that country. So one of the big benefits of these international collaborative things like AtlantOS, like Ocean Gliders, is to build that international support to do this, and build so that we can go to our national agencies and get the support to do the work.
Yeah, thanks. And Sarah, we're. Yeah. Okay. Sorry. Go ahead.
If I may add something from the private sector, we've been trying to push gliders for a while since we finally get it. So this international exchange, we see it is a very good initiative, because by using this international exchange, we can convince sponsor to spend money on gliders and those types of measurements, because it's indeed helpful.
Yeah, thanks, Leonardo.
Perhaps before Sarah and Victor are giving their views on this, you might want to take into account a question by Per Fitzek, who's asking, and you might want to address this all, how gliders are intended to be used in the context of ecosystem monitoring going forward. So yeah, by answering the question Brad's asked, you would like to address this too.
So Sarah, you might want to think about that as well, but I'm just wondering about your kind of intentions in South Africa going forward, in terms of, what your ambition is, but also what some of the challenges are, kind of taking Robert's point that there can be opportunities here in this international engagement to kind of work together to kind of help each other overcome challenges.
I definitely think that being involved in more international collaboration helps. For example, we're involved in the SOCHIC project, so that's good. And I think probably one of the biggest challenges for us is dealing with the data. So we need to, we're very much in the infancy. When I look at Scott's project, we still very much need to spin up our data and get it out. I saw there was also a comment from, I think it was from Martin, in a similar vein, asking about how to enhance glider presence in South Africa, to which I responded, we have had some there's been a motivation in the past, and there is some interest to sort of start a national, because we don't have a national center, so a national center for some kind of virtual infrastructure that would sort of host our polar observatory, and I think that would really help. But yeah, more collaboration, and of course, I mean, at the Southern Ocean, there's a lot of interested parties in the Southern Ocean, and we have quite a nice data set. So I think it's just about, and I think that really to make science impactful, you need to really collaborate. So yeah.
I mean, some of these data collaboration issues have been, improved through the work that Victor has done, I think, at OceanOBS. I'm just wondering, Victor, if there are kind of key steps forward that you see that we should, be focused on now. Where are we, and where are we? Should we be going in terms of supporting enhanced data transfer? Scott mentioned the question of tracking data through models. Scott and Robert, and I think that's an issue that's a tricky one. So I'm just wondering where you see us now.
So yes, there is a key steps, and it's and also I think the risk is to not to start with the step number 1 and go directly to step number 2 and 3. The step number 1 is to connect the glider activity with Ocean Glider. And for example, in Brazil, we have made this connection in the past, but it's not operational today, and we always need to improve. And until we haven't set an operational cooperation, I would say the data flow will not happen. And I would say it's about the same thing with the South African gliders. We know activity exists, but we still don't have a good connection to monitor this activity. And I think that is the step number 1. And then when we have set this cooperation and discussion on activity, we can start thinking of the data sharing. And step 3 would be the monitoring of the use of the data. But this is a very tricky question, and it has to be handled globally. And I think we are still, let's say, as a community, far from being able to track the use of data sets in the operational model. But it's something we could do in the future with a good monitoring of the data and a good data flow, and etc. So step 1 is setting up a good connection with the glider groups. Step 2, work on the data flow and the data management. And step 3 would be the monitoring of the use of the data.
I'll just make one point and then pass back to you, Sandra, because I note the time here. But Laurent Mortier mentioned that there's been discussion in the past about this EEZ kind of question, and it's hung up on kind of two issues. One is that gliders are navigable, so they're not like drifters. So this has been a challenge for many nation states. And the other is that gliders make measurements that not every nation state is happy in. Making physical measurements like Argo does has typically not been such a problem. But BGC Argo floats did get the same kind of pass through to enter territorial waters. So I think there is a need for and space for having that discussion to open that door, as I think, Scott, you mentioned earlier. So that's thanks for that comment, Laurent. So I'll pass back to you, Sandra.
Yeah, I think by looking at the time that so we received as well some comments from Maria, for example, looking at the G7 Futures, the Seas and Oceans initiatives, where they are looking for it, or receiving input on how they can help to enhance the regional observing capacities. Or Ziggy mentioning the All Atlantic Ocean Alliance, and that government representatives are very happy to get all the ideas or for solutions you are having for solving perhaps these problems. So thanks for all your comments that are now coming in. But I would like to ask that you to go over to the WonderMe, where we can have then the informal link and where you can see the participants as well and can connect with each other, and we might can discuss these topics there further. But yeah, thanks a lot for all your great inputs. That was pretty cool to see what's going on, and yeah, we are very much looking forward to help you in staying connected or improving the work you're doing. This is going as well in Victor's direction, because at the Ocean Gliders you're looking at the international levels. So yeah, we are happy to cooperate at the base and scale level. And with this, I would like to thank you and see you at WonderMe. Bye, everybody.
Thanks, everyone. Good to chat.
And I post the WonderMe link again. So
yes, please.
Just that you can see it. And please use Google Chrome or Firefox. It's not working at Safari. So for all of you, just click on the link using the right browser, and see you soon. You will have small tables or see people. You can click towards these people and then join them. You will be a circle. Others can come in. So it's really like a virtual coffee break. So looking forward to see many of you there.